All right, boys and girls, welcome back to day 11 of SAT Countdown Review, and today we're going to discuss exponent and radicals. Today I have a little bit of a different type of video for you, so we'll briefly review some rules for exponents and radicals, and then for the rest of the video we're going to do a lot of questions, okay? So this topic is all about how quickly you can solve them because the rules are pretty simple, and we just need to do a lot of questions. So without further ado, let's go and review the rules very quickly. Now, the simplest rule we have is anything to the power of 0 is always going to be equal to 1. Okay. The second one is going to be the multiplication rule. If we have two exponents with the same base, when we're multiplying them, what do? We add the exponents. Okay. Next one about division, x divided x to the power of a, x to the power of b. This is going to be x to the power of a minus b. Okay, what else we have? We have the bracket rule, so x to the power of a, bracket b. Whenever we open bracket, I've seen a lot of students here trying to add them, but that's not the way to do it. We just have to multiply them. So x, a, b. Okay, what else do we have? Negative powers. This is also usually confusing with people, but x to the power of negative a is equal to 1 divided by x to the power of a. Okay, so these are rules for exponents. I also want to mention a few more for the radicals. So we have square root of x. How can we write it as an exponent? We can write it as x to the power of 1 over 2. So the ones on the left, sort of, usually we get like whole numbers, integers, but whenever we have fractions, we can see radicals, and we can treat the same rules that we have here on the left for fractional powers as well. But in general, if we're talking about radicals, we can write it as if we have square root, so let's say x to the power of m, and the degree of the degree of the root is n, we can write it as x to the power of m minus n. So we can go other way around, obviously. So if I have, for example, 3 to the power of, 4 divided by 3, so this 3 is going to be my n, right? And 4 is going to be my m. So this could be written as 3, so cubic root of 3 to the power of 4. All right, let's get to work. I left the rules that we might need on the right for us. So let's do some practice. Again, feel free to pause so you can do it yourself and get some practice done. So which of the following is equivalent to negative x squared times bracket negative x to the power of 5? So we're going to use one of the rules here. So let's leave negative x squared as it is for now. But on the right side, inside the bracket, we can use our bracket rule. So there's this negative x to the power of 5 is going to become just negative x to the power of 5. Now, actually, if you are interested, because there is a coefficient in front of, let me do it this way. So there's a coefficient of negative 1 in front of x, right? So it's in fact negative 1x to the power of 5. And when we open the bracket, it becomes negative 1 to the 5 and x to the 5. Okay, so that's going to be negative x squared times negative 1 times x to the power of 5. Now, since the bases are the same, we can add the tops using the rules. Negative x to the power of 7 times negative 1, and that is going to be just x to the power of 7. So the answer is going to be C. Okay, let's continue. I do want to change my pen, make it a little bit thicker actually. Let's try this out. Yep. Which expression is equivalent to 4 to the power of x plus 1 times 3 to the power of 2x, where x is greater than 0? So again, this is might be a simplification. You can go to the answer through the multiple choices that we were given. Okay, But let's see what we can do here. Now, 4 times x plus 1, 4 times x plus 1, and 3 to the power of 2x. Now, 4 to the power of x plus 1 can be rewritten as the reverse of the addition rule. So 4 to the power of x times 4 to the power of 1, right? So basically 4 times 4 to the power of x. Now 3 to the power of 2x can also be written as 3 to the power of 2x, and that can be 9 to the power of x. Fair enough? So our expression becomes 4 to 4 to the power of x times 9 to the power of x, right? And now we can use some of the rules. So 4 can stay as it is. Now these 4 to the power of x and 9 to the power of x, they don't have the same base, but they do have the same top. So in that case, we can multiply the bottom. So this can become 4 times 9 to the power of x. Okay, which is going to be 4 times 36 to the power of x. So the answer is going to be C. Again, if you're confused with the last piece here, this is basically the rule that we have. So let me see which one it is actually here. xy to the power of m, right, is equal to xm ym. So it's this rule here. Let me see if I can show you this one here. Yes, it's just the reverse of it. So the answer is going to be C. All right, let's see. Which of the following is equivalent to square root, or not square root, 4 and x to the power of 5? Okay, this is going to be one of the radical rules we talked about. I don't see it in this cheat sheet actually. So let me remind you that real quick. We have n, we have x to the power of m, and that's going to be written as x to the power of m divided by n. So let's do that for our equation here. This is x5, this is going to be x to the power of 5 over 4. So the answer is going to be C. All right, let's continue. The expression 25 to the power of 2x divided by square root of 5 to the power of x is equivalent to 5 to the power of kx, where k is a constant. What is the value of k? Okay, now this might seem a bit of a complicated question, but again, in all of these questions, we just have to apply the rules that we know, try to further simplify it. Okay, so let's see what we can do. I don't know what would be the quickest way to do it, because I haven't tried a bunch of them and then compare them. But from what I'm looking at, I see 25, and I know 25 can be written as 5 to the power of 2. Now, why am I thinking that? Because it seems like we have to bring everything to the 5 power of kx. Now, as you do more questions, you'll have more intuition of that. So, 25 to the power of 2x is going to be written as 5 to the power of 2x, and that can be written as 5 to the power of 4x. So that's my numerator. At the bottom, I've got square root of 5 to the power of x. Square root of 5 can be written as what? 5, 1 over 2 to the power of x. Again, now we can use this rule here. Which one? This one, right? The bracket rule. So 5, 1 over 2 divided by x. So x divided by 2. Now this is my numerator, this is my denominator. Now I just need to divide them. So 5, 4x, 5 to the power of x minus 2. Now we can now use the division rule. Where's the division rule? Here. So we keep the base same, but we subtract the top. X divided by 2. And we can now do a common denominator of 2. This is going to be 8x minus x, and that's going to be 5 to the power of 7x divided by 2. Now, what is going to be the value of k k is just the coefficient of x, so in this case it seems like it's going to be 7/2. Now we don't really have multiple choices to pick from, so this is what I got. I hope it's correct, but the idea is again using the rules that we know. Let me know if you get a different answer. So if the square of a is equal to the square of if the square of a is equal to the cube of b, okay, I'm not going to even read the rest of the question for now, just going to represent that first. So square of a square, is equal to cube of b. So this is what I have so far. Where a is greater than 0, fine, b is greater or equals 0. What is the value of x? What value of x is a to the power of x under the square equal to b? Okay, so what value of, okay, so basically the question is, if this is the case, what is the value of x? Okay, now somehow I need to go from the first expression, which is a square equal to b cube, to this one. Okay, now what can I do? I want to represent the left side here, the one I'm looking for, as x/2, right? I can do that. Okay, now these two equations hopefully can be achieved by adding, multiplying, or using something. Now I see that on the right side b cube became b, which means what? Which can mean a lot of things, but let's see, for example, if I do b cube to the power of 1/cube, that would become b to the power of 3 times 1/3, which is 1. So b to the power 1, that's equal to b. Yes? Wait, it's not visible. That's equal to b. So I can take I can power both sides. So I take a square b cube and do 1 cube to the power on both sides. Yes? So what do I get? I get a 2 divided by 3 is equal to b. Okay? Now, I see that a x/2 is equal to b, and I see that a 2/3 is equal to b. So from both of that, I can probably, so x/2 should be equal to 2/3, which means x should be equal to, just cross multiply, 4/3. That's going to be my answer. So if x is 4/3, we will get this equality. Okay, let me know what you get. Which of the following is equivalent to x square to the power of 3/4, where x is greater than 0? All right, x to 3/4. Again, we can use our bracket rule. So x2 times 3/4. Now we can do a little bit of algebra, cancel them out. x3/2. Now I don't see x3/2 here. I don't need to panic, because x3/2 can be written as radical. So this is going to be 2, and this is going to be 3. Now, I still don't see that answer. Does that mean I'm wrong? Not necessarily. First of all, whenever we have 2 here, we don't write it. It's usual square root stuff. But this x cubed can be further simplified. How can that be done? Now, I can write x cubed as x squared times x. And now I can take the square root of that. That's going to be x. And square root of x will stay. So that's going to be my answer, x times square root of x, which is b. Okay? Now, let's continue. Which expression is equivalent to, etc., where x, y, z are positive numbers? Again, the rules are the rules. So, this is not even an exponent rules at the first step. First step is just multiplying 2 brackets. So, If I multiply these two, I will get x squared times x4. I'm just writing them together so it's easy. Y times y negative 3. Now I can apply my exponent rules, meaning if the bases are same, I can add the top. So this rule right here. So x 2 plus 4 times y 1 plus negative 3. That's going to be equal to x6 and y 1 plus minus, this is going to become minus 1 minus 3 is going to be negative 2. So x to the power of 6, y to the power of negative 2. Which of the following is equivalent to square root of x divided by 64 for all x greater than 0? Okay, let's see what we can do here. X 64. Now, we can write it as square root of x divided by square root of 64. And that's going to be square root of x divided by 8. Yes? And I'm checking and I don't see it here. There's only two answers with divided by x, so I'm going to get rid of this one and this one. And a and c are similar in terms of, well, same in terms of denominator. So it's one of the two, but it's not x squared. How do I know? Because I can rewrite it as the radical rule, x to the power of 1 over 2 is the same as square root of 2. So the answer is going to be C. Which expression is equivalent to x to the power of 5 over 6 divided by cubic root of x, where x is not equal to 0? Now, the reason x is not equal to 0, first of all, is because the denominator cannot be 0. That's just mathematical thing. So I've got x, 5 over 6. When we divide, what do? We subtract, actually let me write it this way first, cubic root of x. So x, 5 over 6. I can write the cubic root as what? Let me actually scroll down a bit. I can write the cubic root as x 1 over 3, right? Now I can write, the bases are same, so I can subtract the tops. X 5 over 6 minus 1 over 3, right? Now I can find the common denominator, which seems like it's going to be 6. 6 divided by 3 is 2, so 1 times 2 is 2, and x is going to be, nope, x to the power of 3 over 6, which can also be simplified. If you divide both parts by 3, that's going to be x 1 over 2. x 1 over 2 seems like it's A. All right, continue. There it is. Which expression is equivalent to B97? B9 divided by 7. Now that's a strange one because we don't see any of that here. But the idea is 9/7 can also be rewritten as, say, if you multiply both by 2, it could be 18 divided by 14. It could also be, this is like a proportion scaling thing, right? 21, 27, right? So one of them should be basically simplified to that. So different ways. You can, probably the quickest way to get to just use the answer. So the first one is B. What is first one? B 105 divided by 15. Now, I can see this is definitely not the one, because 105 divided by 15 is definitely more than 1. But 9 divided by 7 is roughly, I don't know what it is, 1 point something, 2, 3. Yes, so this is not going to be the one. 135 divided by 15 is too big. 135 divided by 105 could potentially be. D is 105 divided by 135. This is definitely not it, because this is going to be what? B 105 divided by 135. So denominator is bigger than the numerator, which is not going to be what we're looking for because ours is 9 divided by 7, not 7 divided by 9. So C might be the correct answer. Let's test it out though. 105, 135. What can I do? I can probably divide them by, oh no, wait. No, I wrote it wrong. This is 135 divided by 105, yes. And I can probably divide them by 15 because everything seems like it's 15 related. 105 is what? Is it 6 times 15? I think so. This is 15, 8 or 9 times 15. 9 times 15. Did I do that correct? And this is 7. Yes. 7 times 15, 35. Yes. So 15 and 15 can go, and now we're left B 9 over 7. Okay, so the answer is C. Again, without doing any calculation, you could find the answer just by elimination of the other ones. So it will probably take you, I don't know, 30 seconds in the exam, but it's good to double check to see if you did it correct. So let's continue. Let me move this question down a bit. Okay. So which expression represents the product of this and that, and where B, C, D are positive? Okay, this is basically multiplication of brackets, right? So it's like A product. It says A times B plus C, right? How do we open that? We say AB plus AC. So that's what we're dealing with here. Now let's do the AB part first. So B6, C negative 2, D negative 5. Now these ones are very easy, but very easy to make a mistake, so you have to be extremely careful. B8, C negative 3. So this is AB part, plus, again, B6, C negative 2, D negative 5, times C4, D5. Okay, so all we have to do now is combine the common terms. So we have B, C, D. We have 3 different ones, right? So I'm just going to mark them here. B and B are same. C, there's no another D on the left. Here we've got B. There's only one B. We've got 2 C's. And we've got 3 D's. Okay, so 2 B's here. We've got B6 and B8. When we add them, so when we multiply them, we add the tops. This is B14. Same goes for C negative 2 plus negative 3. That's going to be negative 5. D will stay as it is. And here we don't have another B, so B will stay as it is. C will become negative 2 plus 4 is going to be 2. And D is going to be negative 5 plus 5. They will cancel each other out. It will be 0. So that should be our answer. Let's see if we have it. B6, C2. It seems like it is this one. B14, C5, D5. Yes. So if X and Y are different than 0, which of the following expression is equivalent to this? Okay, another simplification question. So 8x squared, there's nothing to simplify there. And the bottom can be written as 4x6y4 to the power of 1 over 2. Yes? To the power of 1 over 2. Now, actually, we don't even need to do that. We can first just take out some stuff. So square root of 4, let me basically write it like that. I wouldn't do that in the exam, right? Because it would take too long. But just to explain, these two are same expressions. So 8x squared, square root of 4 is going to be 2. Square root of x6 is going to be x3. Square root of y4 is going to be y2. Right? Now I can simplify a bit further. Divide both sides by 2. This is going to be 4. Divide by x squared. This is going to be x. And there's nothing to do with the y. So 4 divided by x times y square. I don't see that in the answer because all the powers, the answers are with negative, so I can do 4x negative 1, y negative 2. C. Okay, that's all. That's all. This video is about 20-25 minutes. So my goal, again, we're getting closer to the exam. It's very important that we do a lot of questions, and exponents is pretty easy. Again, if you remember the rules, which you don't have to just sit down and memorize the rules, you just have to do a lot of examples and eventually you'll remember them. And that's all I want to say for today. That was day 11. Thank you for tuning in, and I will see you guys in day 10.